Hello, this is a short video presentation on imaginary numbers. Now, imaginary numbers are part of our number system. They follow essentially the same rules as everything else that we've already done, but they are a little bit different. Imaginary numbers and real numbers form what's called the complex numbers. So all numbers are either real or they're imaginary. And in the imaginary numbers, we have the square root of negative numbers. And we've always been taught that the square root of a negative number doesn't exist. That's because it's not a real number. Now, personally, I believe that these numbers are badly named, both the real and the imaginary, because they're all real. They're all part of a system. But the square root of -1 is the number I. I is not a variable. I is a number. It's the square root of -1. This is called the pure imaginary unit. Pure imaginary unit. And once you accept that the square root of -1 is I, pretty much that's all there is to it. If the square root of 4 is 2, and I always ask why, because 2 times 2 equals 4, and that's this number right here, then if the square root of -1 equals I squared is equal to -1. For the same reason. We had 4. The square root of 4 is 2 because 2 times 2 is 4. Square root of -1 is I. That means I times I is -1. All right. Now, let's think about this a little bit. If I squared is -1, what's I cubed? I cubed is equal to I squared times I. I squared is -1 times I is equal to -I, or the opposite of I. I to the 4th is equal to I squared times I squared. And I put this little funky tail on my I's. I don't know why, I've always done it. I squared times I squared is -1 times -1, or 1. So, we have I squared equals -1. We have I cubed equals -I, and I to the 4th equals 1. So now my question is, what is the square root of I to the 14th? I to the 14th, whoops, that's no good. All right. I to the 14th would be I to the 4th times I to the 4th times I to the 4th times I squared. I to the 4th is 1. I to the 4th is 1. I to the 4th is 1. So I squared, remember, is negative 1. I to the 14th is negative 1. Now we could have done that easier by going 14. There's 14 i's. We have them in groups of 3. I'm sorry, we have 3 groups of 4. We have them in groups of 4. So we divide by 4, and we have 3 remainder 2. Why 3? There's 3 groups of 4, and the remainder 2. Well, all we're concerned about is that remainder. So if I had I to the 21st, if I had I to the 21st, I would take 21, divide it by 4, goes in there 5 times, so there'd be 5 groups of 4 i's, and a remainder of 1. So I to the 21st is just I. Likewise, some you can do in your head, some you can't. We have I to the 237th. So now I take 237, I divide it by 4, I get 5. 5 times 4 is 20. 37. 9 times 4 is 36. Remainder 1 equals I. Okay, a couple more things. One is you're going to be asked, as we've been doing all unit, to simplify radicals. Simplify. So if I ask you to simplify the square root of negative 8, that's equal to the square root of negative 1 times the square root of 8, or I times square root of 8 is 2 square root of 2. 8 is 4 times 2, square root of 4 is 2. And we write that in this manner. 2i square root of 2. I is always after the coefficient, if it's rational, but it is before a radical. It is always before the radical. So you would write it as 3i or I square root of 2. Or if there's like this, in between the two. So let's look at one more. Square root of negative 16 is I, and it's equal to, square root of 16 is 4. It's equal to 4i. Square root of negative 16 is 4i. All right, last thing, we talked about, at the beginning I mentioned complex numbers. Complex numbers. And they have two parts. They have a real part and an imaginary part. And we always use the letters to describe it. A for the real part, B for the imaginary part, BI. I is the imaginary unit, B is the coefficient of it. So they would be written like 2 plus 3i. So this is our complex numbers. All right. And tomorrow, what we're going to be doing is adding, subtracting, and multiplying these numbers. All right, I hope this helps you out. I hope you understand this, and we will be working on this come Monday. All right, Enjoy your weekend and have a great day.